Before doing advanced level study, it is important that we understand the basics of the molecular dynamics simulation. Molecular dynamics simulation is a computational technique used to study the behavior of molecules and materials at the atomic or molecular level. The basic idea behind molecular dynamics simulation is to simulate the motion of individual atoms and molecules over time using classical mechanics or quantum mechanics and to observe their interaction with each other and their surroundings. The main steps involved in typical molecular dynamic simulations are: choose a system to study. This involves selecting the type of molecule to be studied and setting up the initial conditions such as the starting positions, velocities, and energy of the particles. Second, define the force field. A force field is a mathematical model that describes the interaction between the particle in the system. It includes parameters such as bond lengths, bond angles, and torsional angles, which dictate the strength and direction of the forces between the particles. Third, integrate the equations of motion. Using the force field, the equations of motion can be derived and integrated numerically over a small time step. This involves calculating the position, velocity, and acceleration of each particle at each time step. Fourth, simulate the system. The simulation is run for a certain length of time during which the positions and velocities of the particles are updated at each time step based on the calculated forces. The trajectory of each particle is recorded and the statistical analysis can be performed on the data. Fifth, analyze the results. The results of the simulation can be analyzed to gain insights into the behavior of the system, such as its thermodynamic properties, structural properties, and dynamic behavior. Molecular dynamic simulation can be used to study a wide range of systems, for small molecules to large protein and polymers, and can provide detailed information about their behavior that is difficult to obtain experimentally. However, they also have some limitations, such as the need for accurate force field and the computational resources required to run large scale simulation.